My name is Yasuka, and I'm a PhD student from UCL. This is a joint work with Anton, another PhD student at UCL. And the project is about extreme rainfall and service sector vulnerabilities, evidence from transactions in Uganda. So to motivate a project, so this project is about extreme rainfall. And it's really increased frequency and intensity by climate change these days. And low-income countries are especially vulnerable. Not only like climatically, they experience more shocks, but also because they lack capacity to adapt to it. So government doesn't have enough resources, or maybe infrastructure is poorer. And there's been like a lot of like anecdotal evidence saying that in these countries, floods, drought, landslides, or heat waves are increasing. And our interest is in Uganda. And there's been a report saying that the pattern of wet or dry season has been changing. But if you think about like how these shocks affect the economic activities, you really need to think about like which sector or like what kind of individuals you're looking at. So if you're like interested in agricultural producers, these people are like definitely vulnerable because their harvest is affected. And for manufacturing firms, there's been increasing evidence about their production is disrupted, labor productivity is dropped, or maybe there could be indirect effect from transaction networks. And our interest is in urban areas, like urban firms, and they actually experience a lot of flash floods as a result of extreme rainfall. And this is because their city's expansion is not catching up with their drainage system, is not catching up with the city's expansion. So this is like what typically happens in Uganda, Kampala. This is a capital city, and you can see that whenever there's a rainfall, extreme rainfall, there could be a flash floods happening, but the water goes away like after 2 or 3 hours. And it really stops every single economic activities, because many people move with the bikes, and not many people have access to cars, and there's no tube or like underground infrastructure. So it really disrupts everyone's activities. So this project asks like, what is the effect of this kind of climate shocks on economic activities? Our interest is in urban service firms because majority of firms in low-income countries are located in urban areas, and they are mostly service sectors. Of course, population-wise, there's a large share of population is engaging in subsistence agriculture, but most of their economic activities in urban areas are done by service sector firms. We also analyze the effect of extreme rainfall, and this is because this is by far the most significant climate risk for urban residents. But we need to be careful about like calling these shocks, because this is less severe than flooding, but much more like frequent and recurring. And there's another like technical aspect of choosing extreme rainfall as an explanatory variable, because it's really hard to detect flash floods in the urban settings. We actually tried a lot of like satellite images from NASA or like Dev Patel's recent development on flash floods, but it's really hard to detect water surfaces when there's building. So we thought like maybe looking at extreme rainfall is a more accurate measure to proxy for flash floods. So research question is the following: how are urban service firms in low-income countries are affected by climate shocks, and especially by extreme rainfall? We studied this question in the context of Uganda. So in relation to literature, our project speaks to several strands of the literature. The first is, of course, about how climate shock affects firms. So there's been a lot of debate going on, and maybe the overall argument is that climate shock is negatively affecting firm performance. Maybe probably our paper relates most closely with the spatial linkages and firm transactions, but our paper stands out in terms of that we study the effect of less severe but frequent shocks rather than major shocks. And second part of literature is firm-to-firm transaction network and shock propagation. So maybe the famous paper is about Japan's earthquake and how it affects their supply chain networks. And of course, Claire's paper about flooding in Pakistan is probably closest to ours. But surprisingly, all of these papers are looking at manufacturing sectors. I'd like to know if someone knows anything about shock propagation in service sectors. So our paper contributes to this literature by looking at how service sector firms has different kinds of vulnerabilities in firm networks and shock propagation. And lastly, there's been a lot of debate going on about how current developing countries are different from past current developed countries. So many low-income countries, like African countries, are kind of like skipping their mature industrialization these days. They're like transitioning from subsistence agriculture to rapid expansion of urban service sectors. And there's been a lot of debate going on about whether this kind of service-led growth path is viable. So our paper argues like if this is really how service sector is vulnerable in the era of climate change. Okay, let me introduce it. Yes.
Something. So just to understand, so in your setting, what we're going to be thinking about is like the relationship between rainfall, like the channel linking rainfall is this flash floods that disrupts transportation somehow in the cities. Is this a sort of damage function you have in mind? Or also productivity of people is something that you have specifically in mind or anything else?
Yeah, we are not thinking about transportation link. The thing is like we can't really see the mechanism from the data. But our interest is like how extreme rain disrupts firm performance, like directly and indirectly. So first we look at how firms are like disrupted, like when they are hit by the shock, and second, how they are like indirectly affected through transaction networks. That's right.
But regardless of what you can tease out from the data, do you have any prior that in Uganda, in this setting, in the service sector there, what should we inquire, like, a flash flood should affect a consultancy firm?
So what we have later in the slides is that demand is a really important channel. So it really affects their like downstream consumers, and then it propagates upstream. So that's their kind of different argument from the manufacturing propagation.
Makes sense.
Okay, so data. So we're using confidential data from URA, Uganda Revenue Authority. So actually accessing this data is a kind of a major effort that we've made because we need to travel to Uganda each time to analyze the data. So I actually traveled 8 times already. And we're using this value-added tax, VAT returns. And it's like really cool data that has like monthly record of total sales and purchases for almost 10 years span. And in the appendix, you can see like what kind of firms are transacting with which firms and its date, transaction volume. But this data is covering the universe of former firms, of like former VAT eligible firms, but not necessarily informal firms. So firms are required to pay VAT if their annual turnover exceeds $40,000, which is quite enormous in Uganda. So I will later contrast these firms are different from informal firms. So in the raw data set, there are about 40,000 VAT reporting firms, but the data set is of course not perfect. So we needed to drop quite a few observations, like firms that didn't that only returned VAT once, or they reported all zero sales or purchases. And we wanted to like see the shocks happening to these firms by location. So we also dropped firms without this information. And industrial sector is also another important part of our analysis, so we dropped them too. And finally, we also dropped primary sector like agriculture or mining, because these are like really exceptionally big firms. So agricultural formal firms, they're like typically coffee exporters, and they are like, first of all, they are small in number, but they're like, their size is big and enormous, and we wanted to exclude the kind of like exceptional firms. We also excluded multinational firms for the same reasons. And our final sample consists of like 30,000 firms with 1.4 million firm month observations. Okay, let me introduce you some facts about Ugandan economy. So first of all, many of these former firms are concentrated in urban areas, especially in Kampala. So our sample consists of like maybe 65% of firms are in Kampala, this dark shaded area. And maybe 75% are in this greater metropolitan area. But you can also see some like darker red colors in cities, and these are all like urban areas. Second fact is that many firms are in non-tradable sectors like wholesale, retail, or services. So this compares their like census stats, which includes their informal firms, and VAT data is just formal firms. So if you look at the census, it's crazy that 55% are retail sectors, and these are mostly informal ones. While our VAT data, we only have like 13% of retail firms, but still their service sector accounts for the large share, and manufacturing is only for like 7.5% of all samples. And actually, we will look at age as a like important component of their firm growth. And it's really striking to see how firms increase sales as they age. So if you're in the like first year of business, you typically have like lower value. And then like if you continue to operate until like 10 plus years, your mean sales will be like almost triple of your first years. And maybe the growth rate is a bit slower for services. Fourth fact, so it's not only about the sales. Oh, yes.
You have an idea, any prior of whether the informal firms would be more or less affected, to have an idea of whether we should interpret your results more as an upper bound? Or...
Yes, I think our results we're going to show is your upper bound. So later we're planning to do a survey where we plan to like sample informal firms as well. So there we hope to see some like gradation of shocks happening to informal and formal ones. Okay, so fourth fact is that it's not only the sales, but also the number of transactions or buyers that these older firms are better at. So if you're like 10 plus years old, you typically transact with like 17 buyers per month, and you have like 65 transactions per month. But if you're in the first year of business, it's going to be four buyers per month, 14 transactions per month. And finally, if you look at your like sales, how sale flows from like seller to buyer, you can see which sector is important upstream and downstream sectors. So this shows the left-hand side is seller and right-hand side is buyer. And you can see that the major flow comes from manufacturing to wholesale and also to retail. And it's not very visible, but probably 15% or 20% of all the sales go to like wholesale, retail, and other services. And this is for total value, but if you look at seller buyer pair, it looks a bit more even out. But still, like wholesale manufacturing could be important upstream sector, but wholesale is still the important downstream sector too. Okay, so these are the interesting facts about Uganda. Let me introduce rainfall data that we are going to use. So this is your standard Area 5 analysis data. And it's actually hourly, but we will aggregate it to daily precipitation. And it covers the entire Ugandan space, and it's available from 1950 to now. So our firm data is from like 2013 to 2012. So we will use the 1950 to 2012 as a reference period. So how we construct the extreme rainfall shock is very simple. So you have a like grid cells for covering Uganda, and for each grid cell we calculate whether this date can be called as extreme rainfall day, and if it exceeds your mean plus 2 standard deviations of the historical average. And then you bring this grid cell level analysis to sub-county level measure, so that we can merge with the firm level data. And this sub-county level rainfall measure is a weighted average of the areas covered by grid cells. So here, blue lines are grid cells, and the black lines are sub-county borders. And the gray shaded areas are Kampala, the capital city. And if you take this, say this gray sub-county, maybe 80% comes from this square, probably 20% comes from this square. So you take the weighted average between these grid cells.
Do you get a lot of variation within cities?
Yes, I'm gonna show you that.
Most of these data, the weather data are interpolated when construction, right? So even if they're super fine grained, there's a lot of spatial correlation. So it's great if you get a lot of within city variation.
Yeah. So then like we sum it up to monthly level. So our exploratory variable is ER, which is number of extreme rain days per month. And it doesn't take integer values because this is a weighted average of the areas covered. And on average, there are like 1.07 days of extreme rain per month. But it's there are more extreme rain days in wet season and less days in dry season. So here's your like variation of extreme rainfall by year. So the median extreme rain days per year is like 13 days. But you can see that 2019 was a quite like rainy year. And even within a year, there could be like variation across months and geographically. So February is a dry season, and you can see that there's not a lot of rain. But October is a rain season, and you see there's a lot of extra rain happening. Okay, so here's your estimation method. We just employ a very simple two-way fixed effects regression using firm and month fixed effects. The explanatory variable is just, as I explained, ERSD, which is your extreme rain days in your sub-county. And the assumption is that this ER is independent of other firm time variant shocks. Okay, let me show you the main result. So this is our headline. The x-axis shows you firm age, and y-axis shows you the effect of extreme rainfall days. There's a very striking pattern of like, if you're young, then you typically experience like 12% sales drop as a result of 1 day of extreme rainfall days. But the the negative effect dies out as you become older. Yes.
Since you mentioned demand is a huge channel, do you see inferred as an export as an adaptation mechanism?
You can see that, but we haven't seen that. Yes.
Seems interesting.
Yeah, right. Yeah. Actually, our initial idea was like this local shock is exporters are insulated from these local shocks. So yeah, we actually looked at it, and indeed exporters are insulated. But yeah, we're not gonna show that result today.
But maybe it also forces them to.
Yeah, that's right. Well, if you see this result, you might wonder, like, is this by learning or selection? And we have answer to that. So actually, this is your same set of analysis, only using the surviving firms. And we can still see this kind of age dynamics. So we can probably say this age effect is coming from learning. And this is your plot for number of transactions and number of buyers. So it's quite interesting that it's not only the sales, but transactions and the number of buyers are also dropping for younger firms. I'm not sure if you can see this table clearly, but this is your heterogeneity by sector. And only negative coefficient appears on wholesale, retail, accommodation, food, and other services. These are all like downstream sectors. So maybe you would think like, okay, so these firms are probably most affected, most vulnerable. But actually, age pattern exists across all sectors. This is even worse able to show in this large room. But so I think like our current idea is that maybe this heterogeneity comes from different composition of firm ages. The downstream firms like wholesale or retailers are generally younger than manufacturing or construction utility firms. So it's just because these downstream firms are younger makes them more vulnerable as a whole. So now we would wonder, like, where does this shock come from? Like, what is the mechanism of it? So we can't really look at the like transportation links or what's really happening, but we try to separate the direct effect and indirect effect by leveraging the transaction data. And here I added the extreme rainfall of my own sub-county and your buyer's sub-county. So for example, I'm in London, I'm operating in London, I'm selling to Manchester, and I'm adding extreme rainfall of London and Manchester to see how the own rainfall shock and Manchester's shock is different. But this is, I'm only using the transactions between different districts to ensure that there's less spatial correlation between own rain and buyer's rain. And this is quite interesting result. And it's not very clear what's going on in the first 2 years because many young firms don't really transact with different districts. But if you look at 2 to 3 years or 3 to 4 years, then it's quite clear that the negative effect comes from buyer rain. So it could be that these firms are experiencing negative shocks because the buyers, there's less demand from the buyers, and that could be the vulnerability of these service sector firms are facing. So summary of the results. So when we saw the direct effects, young firms were especially affected, negatively affected, but the effect disappears as they age. And we also saw that heterogeneity of the sectors, and it seemed like service sectors like wholesale retail or accommodation are more vulnerable, but age explains the heterogeneity. Probably the different age composition explains it. And we also found that selection doesn't really explain this pattern. In terms of their indirect effects, we found that buyer's rain has a significant negative effect on sales transaction. So the previous graph was only about buyer's rain, but we also looked at it for seller's rain and own rain, and we didn't find a downstream propagation. So we found that upstream shock propagation is probably stronger, and especially this explains why younger firms are more vulnerable to these kind of shocks. And this is a point that we stand out from the previous literature, because many literature that studies production disruptions in manufacturing transaction network says their suppliers are disrupted, and then your production is also affected, which is a downstream propagation. And they didn't really find their upstream shock propagation. So maybe our results could tell that in an economy where sectors are like heavily skewed to service sectors, and service sectors are like by nature probably dependent on demand, local demand, they are probably more vulnerable to local demand shock and its upstream shock propagation.
So 2 other mechanisms. One is that maybe there's differential credit constraints by firm age, or just access to other adaptation tools. And the other is maybe older firms are just located in different places. Did you check the distribution of rainfall by firm age?
You mean
is the magnitude of extreme rainfall shock smaller for older firms?
So actually, for their location, we can see the relocation patterns first of all, and there could be a systematic patterns of like older firms are like located in a better place. We haven't really looked at it, and it's actually anecdotally speaking, manufacturers are in a like better place, like they are like up in the hill, so they are more like less likely to experience flooding, I guess. So that could also explain the result. Okay, so let me move on to their framework, but this is still a work in progress, so I really want to have your suggestions or comments for this. So remember, extreme rainfall here is a frequent shock. So firms experience this kind of shock like probably every month in dry wet seasons. So it can be considered as a like recurrent bad state. You remember like when you take like PhD first year course, you do a macro like there's a random draw like good state and bad state. So we can think of this shock as a bad state. So we're interested in also these strong age patterns means that comparing the good state and bad state, the younger firms must be experiencing a lot of fluctuations in sales. So even within a year, like you have many good state and bad state, and the difference is like 15%, then that's a lot of variance. But for older firms, the variances should be smaller. And also we found that the shock appears to be driven by the demand side. And there's been like some other papers in Uganda talking about access to customers, but demand constraint is a really important factors for businesses in Uganda. And even in the context of Kenya, this Ega et al. Paper is talking about how demand is important, and demand fluctuations or inability to predict demand may pose challenges. And what we found is like that's probably true for younger firms, and especially younger firms may not have enough capacity to respond to this kind of demand uncertainty. So we are like trying to think in this framework, like what is the like implication of these demand fluctuations or like uncertainties about firm growth, and how firms are like learning, and why we see that kind of like clear patterns of age. So this is their sales volatility by age, and as expected, youngest firms experience like very high level of volatility, while older firms, like as you age, the volatility level becomes like lower and lower and kind of converges to the same level. So let me introduce a very simple framework. So single firm faces uncertain demand D, and before demand is observed, firm needs to decide on the capacity. And this firm produce the minimum of capacity or demand. And so this capacity is K, and demand is explained as a mu plus epsilon, and epsilon is a demand uncertainty. And firm sales Q, which is a minimum of K and D, and skipping all the deviations, key result is that higher sigma, higher variance predicts lower profits, and higher sigma also predicts higher investment. So you invest too much, and your capacity is like kind of idle when you are in the bad state. So with higher uncertainty, firms could experience lower profits despite having higher investments in capacity. So this is the end of the presentation. We are like still trying to develop this framework to explain how firm is like learning and growing and the demand uncertainty. We're especially trying to see like how firms are trying to reduce their uncertainty by choosing best customers, like establishing like nice customer portfolio. And we also got IGC funding, and we got permission to sample VAT firms. And in that way, we can probably sample informal firms around these firms to see their like different mechanisms of shocks happening to these type of firms, and also their adaptation strategies. And yeah, this is it. Thank you so much.
Do you have information regarding the firm's latitude and longitude location?
Sorry.
The location.
Location?
Yeah, the latitude and longitude.
No,
location.
we can't get the exact location. What we can get is a sub-county level.
Okay.
And that's there are like 1,500 sub-counties, average size 100 square kilometers. So we know that that's not a perfect way to like measure the shock, but yeah, that's